3 by 3 matrix using row operations. Look in the upper left-hand corner. We are trying to get a diagonal of ones with zeros to the left, and these numbers A, B, C, D, E, F, they can be anything. So here is our linear system in 3 variables, which I've converted in this first matrix. So you can see each row represents the coefficients on X, Y, and Z, and this column here is of the answers. Now, the first step I'm going to do is looking at the rows. I'm just going to switch rows. This bottom row already starts with a 1, so I'm just going to put it on the top. It'd just be like if I arranged this last equation first. It doesn't make any difference to the final solution. So that is this second matrix. The second matrix has, sorry, having troubles here. The second matrix, I'm going to add the first and the second row together. So I'm going to add the 1 and the -1, the 2 and the 1 across. And so the third matrix down here, I have the first row, which is the same. Now in the second row, I have 0, and 2 and 1 gave me 3, and 2 and -2 gave me 0, and finally -1 and -11 gave me -12. So whenever you want, so the next thing we want to do is get rid of this 4 here, because remember we have to work down the column. So I'm going to multiply the top line by -4. And so if I do that, I get -4, -8, -8, and +4. Okay, so now I'm going to add this line to the bottom line. And when I do that, the resulting matrix looks like, let's see if I can get back to a different color. It looks like I have the original row, 1, 2, 2, -1. Then I have the 0, 3, 0, -12. And now on the bottom, I have 0, -7, -7, and 7. Okay, so now 1, 0, 0, that fits the form that we have in the left-hand corner. And so now I'm going to work down the next column. So the next thing is that this 3 needs to become a 1. So whenever I'm making ones, I always multiply by the reciprocal of the number. This time I'm going to use 1/3. And so my next matrix, let's see, I was using blue. My next matrix will be same row on top, 1, 2, 2, -1. Now I have 0, 1, 0, -4. And on the bottom, I have the 0, -7, -7, and 7. Okay, next we need a 0 where that first 7 is in the third row, because we're working downward. So I'm going to multiply the second line by 7. Okay, why not the first line? Because 7 times 1 will give me 7, and 7 and 0 will give me a 7 in this position. I don't want to change that 0. So if I did multiply it across, I'd get 0, 7, 0, and -28. And now I'm going to add this line to the bottom line. So my next matrix, we have 1, 2, 2, -1. Then we have 0, 1, 0, -4. And if I add 0 and 0, I get 0 here. If I add 7 and -7, now I have 0. I'm going to add 0 and -7, so that leaves me a -7 here. And then -28 and 7 leaves me with -21. Okay, got that 1, 0, 0. We have 1, 0. Now we just need a 1 here. So like before, we're going to multiply this line by the reciprocal, which would be -1/7, because we want a positive 1. So I'm finally down to 1, 2, 2, 1, 0, 1, 0, negative 4. And on the last line, we have 0, 0, 1. And that gives me a positive 3. So what have I found? I have found out that z is 3. Y has to be negative 4. And then if we substitute these back into, let's say, the original equations, any of them, let's go x plus 2 times negative 4 plus 2 times 3 should equal negative 1. And we get x, this is negative 8, and 6, which is negative 2, is 1. So x is, that's a negative 1. So x is 1. So your final solution is 1, 3, negative 4. I hope this has helped you understand how to do this, to solve these, and that you're able to solve the assignment tonight. Thank you.